Fifth graders. Good morning, good morning, good morning. It's Monday, March the 23rd, and we are getting ready to start week 2 of e-learning. And I know that it's been a crazy first week, right? We never expected that this would happen, but it has happened. And you have started your e-learning experience, which, as Miss Lee posted earlier, that this is really what college looks like. It looks like kids getting online and having posts and reading and things to do and looking at videos. And you guys have been troopers. I know that you guys have went above and beyond to really make sure that this works, and I appreciate you. It looks like we're going to be in this for the long haul, at least for another month. So I just want to encourage you to be diligent about doing your work. I'm here. We're going to try to do some virtual things this week with you, so look out for my posts and things like that. But let's get started with the lesson. We just want you to know, though, that we think that fifth grade rocks. Oh, yes. We think that fifth grade rocks. We love all of you and keep on pushing, okay? All right, I'm going to start with the lesson, okay? Dr. Milam wants to start with the 2 problems that I asked you to do in your packet. And I think that the confusion might have been that it was page 21 and 22, but it was actually problems 21 and 22. And I asked you to take a picture and post it to me. So a lot of you reached out to me and said, well, how do you do that? And so we'll talk a little bit about doing that on Class Dojo. Okay, so I'm going to be asking you to do a couple things on Class Dojo between a video, posting pictures. You're going to do it straight from there through your student account. Okay, and so we'll talk about that a little bit later. But for right now, let's get started with this particular problem. All right, it says enter your answer in the box, and so you know that this is in print form. So how in the world would you do this? Based on what we've learned so far, let's turn this actually into a fraction. So let's say this fraction is 35 hundredths, and we know that we're going to write it like this. This is new learning. We've really not learned how to do this before. I taught this to you last week. Miss Lee taught you how to multiply this through the standard algorithm. And so I am going to do that over here, but I want you to see this problem via the new information. So this is 1 and 5/10, or 15/10. Do you remember this from last week? Remember that this is the same thing as saying 1 and 5/10. And remember that the 1 can be written as 10 over 10. And then plus the 5/10 to give us 15/10. My mouse is working really great this morning. All right, so we're going to multiply these two. So we know that 100 times 10 is going to give us 1,000. And then we do actually have to do 35 times 15. Okay, so, and that's going to set us up for when we do the standard algorithm just as well. Whoops. All right, so how do I multiply this? I'm going to go ahead and write this in words here. Remember that this is 35 hundredths here. Yeah, Dr. Mom's been practicing just a little bit. All right, so this is 35 hundredths. And then this was what? 15/10. So remember that this is tenths. Okay, so I'm just going to multiply this. And I wrote this here so I don't forget that I'm actually multiplying decimals and not whole numbers, okay? So I'm multiplying, so 5 times 5 is 25. And then 5 times 3 is 15, plus 2 is 17. All right, I'm going to put my 0 for my placeholder there. And then 1 times 5 is 5. And 1 times 3 is 3. Remember, you had already used this. Okay, I don't want anybody to get confused with that. And now I'm going to add these two. You guys remember how to multiply. All right, 7 plus 5 is 12. Carry your 1. And then this becomes 525. Now look at the number of decimal places that you have here. You have hundreds, you have tens, so this is going to be thousands. All right, so that means I'm going to put that number right here, and I've got 25 thousandths. Or I can write this as a decimal. It did not tell us what form to put it in, okay? So this is actually acceptable. But just for the record, we're going to write this as 525 thousandths, okay? And that's your answer. And because it did not tell us what form, this is acceptable just as well, okay? All right, let's go on down to the other problem. Okay, so this one's a little tricky because a lot of you put 3 as your answer. And so let's just see if that's the right answer, okay? All right, so Jim uses ribbon to make bookmarks. Okay, how about we say that, let's see. How about Danisha? Danisha, if I can write it. Let's say Danisha. Let's write her name here. Danisha, I hope that I spelled this right. Danisha uses ribbon to make bookmarks. Okay, and so she has 9 feet of ribbon. So what I'm going to do right now is just draw 9 boxes, okay? And this is 9 feet, okay? And so there's a reason why I'm doing this. You know, Dr. Malum always has a reason for why she's doing that. And remember that this is feet. So I'm going to draw this long box, and I just want you to see that this is like 1 foot. So each one of these boxes is a foot, okay? 1, 2, 3, 4, 5, 6, 7. It's not drawing the scale here. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so this is 9 feet. Is everybody with me on this? Okay, 9 feet. Let's get rid of that because that doesn't look like. That's better. All right, 9 feet. So it says that she uses 1/3 foot. 1/3 foot. So this right here is the same thing as saying 1/3 of a foot. Not 1/3 of 9 feet, but 1/3 of a foot. So if I take this box right here and divide it into, let's change our color here. If I divide that into 3 parts, because it says 1/3 of a foot, here's your foot here. And if I make this into 3 parts, then I have only used 1/3 of a foot. Right. So how many ribbons, or excuse me, how many bookmarks can I make from this 1 foot? It says that she uses 1/3 of a foot of ribbon to make each bookmark. So I can make a bookmark with this much ribbon, and this much ribbon. Wow, so I can make 3 bookmarks out of just 1 foot. Well, I have how many feet? I've got 9 feet, and so I can do 3 times 9, because for each one, I can make 3, and so forth and so on. So that means that I can make 27 bookmarks. Hmm. 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 Yeah, 3 is not the answer. I could make 3 out of 1 foot, but I have 9 feet here, so I can make 27 bookmarks. Okay. All right, all right, all right. All right, let's keep going. Let's go into our lesson for today. Tough stuff. I'll just warn you right away because there's tons of word problems, nothing but word problems on here. Okay, and I wanted you to build your muscle a little bit around doing these word problems. So I'm going to do the ones in the problem set, like I did last week. You're going to do them along with me in your book, and then you're going to tackle the homework, and I'll send the homework video. Okay, all right, so here we go. So a vial contains 20 milliliters of medicine. If each dose is 1/8 of the vial, how many milliliters is each dose? Express your answer as a decimal. That's another part of our directions. Express your answer as a decimal. So I've got a vial that contains 20 milliliters of medicine. Let's see. Can we get something better than that? Probably. All right, let's try. Let's do this in black. All right. So, oh, Dr. Milo, what's happening with you today? All right, let's try it again. All right, here we go. That's not even better. Ah! Is anybody laughing at me? I hope so. All right, let's try steady, steady, steady. Steady. It's hard to do it with the mouse, guys. I have no clue. All right. So it says that so first of all, this is 20, right? So this is 20 milliliters of some kind of medicine, right? Hope this person doesn't have corona. All right. So 20 milliliters of medicine. Each dose is 1/8 of this. So you know what I'm going to have to do, right? I'm going to have to divide this into eighths. And so here's my tape diagram trying to divide my milliliters into eighths. Like 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then 7, 8. Okay, so I've got each dose, okay, is 1/8 of the vial. So here's my, whoops, let's try that again. Here's my 1/8. Okay, because this is in eighth, so that means that I've got each dose is 1/8. First of all, if I took the 20 and divided into eighths, oh boy, can I do that? I can't really do that. Um, um, Without getting a decimal because there are what? There's not the same number in each of these 20s. Okay, meaning that 8 can't go into 20 evenly. I wonder what can go into 20 evenly. That relates to eighths. And we might be able to look at this in fourths, okay? So this is just another way that we can solve it. So if I look at this in fourths, let's see if I can do that. So here's 1. Just bear along with me for a moment. 1, 2. Let's keep going, Dr. Milo. 3, and then 4. So what I just did was relate this 1/8 into fourths. And remember, we can create equivalent fractions doing that. Oh boy, it's been a while since you did that. So what I'm trying to say right now is that I'm trying to get this to a place 1/8. Look at this. I want to turn it into fourths. How much is that? What do you think? What do you think? What do you think? How much is that? All right, well, let's keep going. All right, so look at this. I have fours now, right? So that means that two of these vials here, okay? All right, so I've got each dose is 1/8. I've now divided this into fourths. So 20 divided by 4 is 5. Is everybody with me? So this entire piece is 5. Set to, don't get too confused, girl. I'm just giving you a hard time. So how much is in the fourths? There are 5. So how much would be in half of that? Would be what? It would be 2.5. Oh boy. Yes, this amount is 2.5. Okay. Another way that we can look at this is taking what? 1/8 of 20. So 1/8 of 20. So how do I do this? We already know how to do that. 1/8 times 20. All right, which is going to give us what? 20 divided by 8. And so if you just do the math, how many 8s can go into 20? Well, if I do 3, that's 24, so it's got to be 2. So what am I doing here? I'm doing really 20 divided by 8, okay? And I'm saying this is 2. 2 times 8 is 16. What's left over is 4. So I'm going to write this as 2 4/8. 2 4/8. All right, which reduces to what? 2 4/8 reduces to a half, okay? And which is what the answer was that we got over here with our tape diagram, okay? All right, so I need to write this as a decimal. So we know that 1/2 is the same thing as what? Well, sometimes it's not easy to see, so there's a couple things that you can do. And I'm going to take advantage of this division that's right here, and I'm going to extend this for a moment. And I'm going to put a 0 there, and I'm going to drop that down. And when I do that, I get 8 goes into 40. How many times? 5. And my decimal is here, so I need to put my decimal right there. Okay? All right, so 5 times 8 is 40. So that gives me a remainder of 0. And now I have my decimal. The other way, so this is like the standard algorithm way. The other way we could think about this is trying to get 1/2 to an anchor denominator. So like we know that we can get this to 10 or even to 100. That would help us too. So how can we get this? How can we create an equivalent fraction that has a denominator of 10? We can multiply that by 5. So 2 times 5 is 10, 1 times 5 is 5. And so now we can read that this is 5/10. So now we can write this as 2 5/10. Okay, couple different ways. You may like this better. Some of you who really dig division can do it this way. Hope I didn't confuse you too much on this problem. Okay, and so we're going to keep going because we got a lot to do. All right, here we go. A container holds 7/10. Let's make sure that we practice saying our decimals. A container holds 7/10 liters of oil and vinegar. 3/4 of the mixture is vinegar. How many liters of vinegar are in the container? All right, it says express your answer both as a fraction and decimal. So look at this key sentence right here. It says 3/4 of the mixture. What mixture? This mixture of oil and vinegar is vinegar, 3/4 of it. So it's saying that 7/10. Are you okay with me writing that as a fraction? This is 7/10. Okay, so it's saying that 3/4 of 3/4 of the mixture, which is what? 7/10. 3/4 of this mixture is vinegar. So we know how to solve this, right? So 3/4 times 7/10 is 21/40. Okay. So we have our expression. We cannot reduce it because the factors of 21 are what? They are 1, 3. Well, let's see. Let's get rid of that and that. Okay. So the factors of 21 are 1, 3, 7, and 21. And none of those can go into 40. And so this is our fraction, but now it's saying that we need to express it as a decimal. So I can do the standard division if I want to, okay? Or I could try to get 40 to um, I could try to get 40 to a unit fraction. I could divide this by 4, which would give us 10, but 21, that might be an easier division then, or I could just do the regular division. So I'm going to show you both because I think that both methods are definitely worth you doing it. Okay, so I'm going to do this one first. So how do I get this to 10? I divide by 4. That's not easy. How do I get it to 100? Well, it's still not an easy jump. But what if I try 1,000? And you say, well, why would you try 1,000, Dr. Milo? Because 25 times 40 is actually 1,000 because 25 times 4 is 100, and then I've got this 0 here. So 25 times 40 is 1,000. So if I multiply this bottom by 25, then I have to multiply the top by 25. And what am I trying to do? I'm trying to get it to a form where I can easily write it as a decimal. So let's do that. Let's do 21 times 25. And that's pretty easy to do. You may see this a different way, and you can do that. So this is 5, this is 10, meaning that 5 times 1 is 5, 5 times 2 is 10. Let's put our anchor 0 there, and then 2 times 1 is 2, 2 times 2 is 4, and so I'm going to add, and so now I have my top number. And now I can express it as a decimal. This is 525 thousandths. And so I can write that as 0.525. So the moment that my denominator is like 10, 100, 1,000, if I can get that, then I can write the decimal easier. If that way is like you don't get it, all right? So you can do your standard division and add a decimal and add zeros. So let's read this problem. This says 21/40 or 21 divided by 40. Remember that Dr. Milam taught you that a fraction is nothing but a division sentence. So this is 21 divided by 40. Is everybody with me? All right, so that means that 21 is going on the inside, ladies and gentlemen, and 40 on the outside. Can 40 go into 21? No, so there's my decimal right there. I'm going to add a 0. Can 40 go into 210? Yeah. How many times? Well, you got to count by 40s to get to 200, right? So if you see this, this is really saying 4 into 21. Oh, some of you are going to be confused. Okay, let's count by 40s. So we've got 40, you've got 80, You've got what? You're going to need another 40, 120. Another 40 is 160. And then another 40 is 200. So how many 40s are there? 1, 2, 3, 4, 5. 5. So what I was trying to get you to see was that sometimes when you're estimating how much can go in there, and I taught this to you when I first came, 4 into 20 is 5. So you can see that that's going to be very close to your 210. So here's 200 because I did 5 times 40. And then what's left? 10. But now I've got to extend this and put another 0. All right, so 40 goes into 100, where you can think about this as how many 4s go into just 10. Well, that's going to be 2. Okay, so 2 times 40, which we had already done that over here, is 80. So what's left is 20. And then I'm going to extend this one more with another 0, bring that down. Yeah, we brought that down here. And this is a 0. So 40 into 200, we know what that is. That's 5. And there's your decimal right there. 500 and 525 hundredths. Okay? All right, let's keep going. I did not do the tape diagram on this one. You could have done it, but I thought that this was a little bit more straightforward because it's kind of tough when you start to do work with decimals and tape diagrams. It gets kind of tricky. All right, here we go. Here's another one that could be pretty complicated, but if you think about this in whole number increments, then it may not be as tough, okay? So on Andres or Andreas completed a 5K kilometer race in 13 and a half minutes, okay? It's pretty fast. His sister's time was how much? 1.5 times longer than his time. Longer. So we already know that if it took longer, that her time is going to be more than 13 and a half, okay? That's just a little number sense we're working with here. It says, how long in minutes, oh boy, did it take his sister to run the race? So look at this. If it's one, what if it said 2 times as long? What would you do? If it was 2 times, then you would just take this and multiply it by 2, right? Yeah, that's all you would do. So, but this is 1.5 times longer. So I'm still doing the same multiplication as if it was 2 times as long. So there's a couple ways you can think about this. You could just multiply it out, okay? And I know for some of you that see it, we're going to do that. So here's your 13 and a half minutes. So 13 and a half, okay? Are you okay with me converting this into a decimal? Or we could go the other way. Yeah, let's do that. Let's go the other way. We haven't practiced that in a while. So 13, I'm going to write 13 and a half as 13 and 5 tenths. Okay? Times, we already said we were going to multiply, times 1.5. So if you like working with fractions and multiplying that, then you can do it that way. Okay? Again, there's a couple different ways I'm going to show you how to do it. I'll do it with decimals and I'll do it with fractions too for those of you who need it. So remember, we've got to convert this into an improper fraction. So 13 times 10 is 130 plus 5 is 135. So that's 135 tenths times 1 times 2 is 2 plus 1 is 3 halves. And so I can just go ahead and multiply. Remember, it's 10 times 2. This is not addition, so I'm not doing a common denominator. And then I'm going to do 135 times 3. And I'll do that over here for those of you who like this way. All right, and so this is 5 times 3, which is 15. 3 times 3 is 9 plus 1 is 10. And so then 3 times 1 is 3 plus 1 is 4. So I've got 405. All right, remember that we were multiplying these two together. Okay, and so now I'm going to either reduce, or I can make it as a fraction. I'm sorry, as a decimal. So let's divide this. So what's happening here? All right, 405 divided by 20. Well, how many 20s go into 40? Well, there are two of them. 2 times 20 is 40. And so I get 0 left. Okay, I'm going to bring down the 5. Can 20 go into 5? No. Okay, so that means that I have to put a 0 here. 0 times 20 is 0. Sometimes when you guys do division, you miss that step. Okay. All right, so I'm going to put a decimal here, and then I'm going to put a 0 here. Whoops. And then I'm going to bring down my 0. All right, 20 goes into 50 how many times? 2 times, right? All right, so I'm going to bring this decimal up, because that's what you do when you have division of decimals, okay? 2 times 20 is 40. What's left is 10. Oh, this is beautiful, because I can see already that if I extend it one more time, don't move 0. I'm going to put a 0 here, and so 20 into 100 is how many times? 5. So here's my decimal right here. Okay, here's my answer. Remember, I was multiplying these two together, and so my answer so far is 20 and 25 hundredths. Okay? It says that we have to express this in minutes. So this is 20 what? 20 minutes, and how many seconds? Because that's what the leftover this decimal is. So 20 minutes. Okay, so this is what? 25 hundredths is 25 hundredths. And there's a couple ways you could do this. This is a like saying a quarter. Okay, so it's 25 hundredths of 1 minute. Or if you see it, you already are thinking that the answer is 15, right? Because it's like saying a quarter of a minute, okay? If you don't see it, then go ahead and do the conversion, okay? But you ought to be able to see when you do this multiplication, you're going to get 1/4, okay? I'm not going to do it right now, but you do it, okay? Put this over 1, and then you're going to multiply. You get 1/4. You ought to be able to see that 25 hundredths is like saying a quarter or 1/4 of 60. And so I'm sorry, you're not going to get 1/4. You're going to get 15. Okay, 15 seconds. Okay. All right, so it's 20 minutes and 15 seconds is the answer. 20 minutes and 15 seconds. Okay. And that's the answer. Wonder how we're feeling about this. I'm not going to do the tape diagram because I need to do the tape diagram on a few more. So I'm going to leave it like this. If you want to multiply it by decimals and you like that, then you can do 13 and 5/10 times 1.5. And if you see that as 1 and 5/10, then you can go ahead and do the multiplication. Remember that you can write this as 135 what? Somebody tell me. 135 tenths, okay? Because this is in tenths. This is in tenths, okay? And so when you get started, when you finish it, I'm sorry, you're going to get hundredths as your answer like we did over here, okay? I'm going to keep going because I don't want this video to get too much longer and I bore you, and then you stop it. Okay, here we go. Let's do number 4. If you need to replay the video, you know you can, and you know you can always reach out to me for help. All right, a clothing factory uses 1,275 and 2/10 meters of cloth a week to make shirts. How much cloth is needed to make 3 3/5 times as many shirts? Okay, I'm going to do on this problem what I didn't do on the other one, because this is like 3 3/5 times. What if it was just 3 times? Then you would just multiply it. Like I just need 3 of those. So let's do it. Let's do that. 1,275 and 2/10. So what if I just do 3 of those? I just want 3 of those. We'll figure out the 3/5 in a minute because there's a couple ways you can do this. 3 times 2 is 6. 3 times 5 is 15. Carry my 1. 3 times 7 is 21, plus 2 is 22. Carry the 2. Help you along with me. 3 times 2 is 6, plus 2 is 8, and 3 times 1 is 3. And so how many decimal places do I have here? I have just 1. So far, this is how many meters I need as just 3 times, okay? But I also have 3/5. So I've got to multiply 3/5 times the number of meters because I needed 3 3/5 times as many shirts, not just 3. So sometimes if you break it into components, then it might be a little easier. So I've got to take 1,275 and 2/10 times 3/5. Okay, I hope that you're okay with me writing this 2/10 as 2/10. Okay, and I've got to multiply that by 3/5. I cannot, ladies and gentlemen, multiply just these 2 fractions. Okay, all right, because I need all of this. Okay, so how are we going to do this? Are we going to multiply this? Oh, dear Lord. All right, so 1,275 times 10 is just 12,750 and then plus 2. So 12,752 over 10 times 3/5. Really big numbers here. That's why I did not do the 3, because it just would have been even bigger than that. All right, ladies and gentlemen, we want to multiply across. We can do that. We can multiply across, okay? All right, let's do that. All right. Dr. Mom is just checking her notes. All right. Shoe. 10 times 5 is 50. And then let's multiply this by 3. So 3 times 2 is 6. 3 times 5, 3 times 5 is 15. Right, carry the 1 is 22. And I hope that you're seeing that it's the same as that over there. Ha, look at that. All right, so we want to see how many 50s go in there, okay? All right, oh, good Lord. So 50 cannot go into 38. 50 can go into 382. And so that's 7 times. I don't know if you can see that. 7 times, okay? If you don't see it, let's just go ahead and do the division because I definitely don't want to confuse you, okay? All right, so I'm dividing this by 50. We already said that it can go in 7 times. This is 350. If you find an easier way to do this, go ahead and embrace that. This is 32, and I'm going to bring down the 5. Okay? Is everybody with me? 50 goes into 325 how many times? Remember, Dr. Bauman said 5 goes into 32. How many 5s are in 32? That's 6. Okay? Because 6 times 5 is 30. So let's keep going. So this is 300. All right, let's keep going. And we've got 25 left. And I wish we had a 0. We don't. But we have a 6. So how many 50s go into 256? How many 5 goes into 25? That's 5 times. So that's 250. We've got 6 left over. And so we could call it 6/50ths. But let's just keep going. Let's add a decimal. We're going to add a 0. Whoops. And I'm going to bring that 0 down. Who's confused? All right, 50 goes into 60 how many times? 0 times. 0 times. Okay? All right, 0 times 50 is 0. And so there's a 60 left. Now I'm going to add another 0. Whoops. And so how many times does 50 go into 600? Or how many times does 5 go into 60? Oh, Dr. Milo made a mistake. Oh, shoot. All right, I'm going to do a Control Z. I just made a mistake. All right, if we ever make it back to school, that's another marble. All right, let's see. Okay, let's see. I was bringing down 0, and I made a mistake. 50 can go to 60 one time. Ooh, it's Monday morning. All right, so this is 50, and then this is 10, and I'm still going to add a 0. And when I do that, thank God. All right, 50 goes into 100 2 times. Okay. All right, you're going to do better at this than me. All right, so here we go. So I've got 765 and 12 tenths, okay, when I divided that. So now I've got to go back and add that, because remember that was only 3/5 of this. So I have to add that here. I'm going to line up the decimal places. And I'm going to put an anchor 0 here because I need that place in order to add the 2. Okay? All right, so I've got 2, 7, 10, 9. Are you with me on that? 5 and 4. All right? So that means how much cloth is needed to make 3 and 3/5 times as many shirts? I need 4,590, sorry, not and 90, 4,590,072 hundredths meter, woo, of shirts. Lord have a cloth to make the shirt. All right, lots of me talking about how to solve this. You could have just gone straight to multiplying this times this. And if you saw that, when you finished with the division, it would have given you this. But I thought I would take advantage of the fact that I could just first multiply this by 3 and then take my answer and multiply and put it to the side and then multiply that by 3/5. Okay? All right. As I was doing this problem, can be a bit tough here. This problem is, it looks easy on the onset, okay? But it might be a little challenging for you. Okay, so here we go. There are 3/4 as many boys as girls in a class of fifth graders. If there, I wonder, is that true? We did look at ratios before in our class. If there are 35 students in the class, how many are girls? Okay, so we're focused in on girls. There are 3/4 as many girls. There are 3/4 as many boys as girls. So let's start with this. I've got a tape diagram, okay? And so let's just say that this is the girls. Because then it says that there are 3/4. 3/4 of that is what? Is boys. And I'm going to tell you, and I'm going to show you in just a minute why I wrote it as two separate tape diagrams. Okay? Because sometimes it's tough to see these problems. So if there are 3/4 of the girls, the number of girls is boys. So how much does the girls represent? Well, let's use a nice color for the girls. How much does the girls represent? The girls represent, all of this is girls. So how many units are girls? 4 units. It makes this tough. It's a little tough to see this. Okay. How many units are girls? There are 4 units that are girls. Okay. How many units are boys? There are 3 units that are boys. Okay. Or 3 boxes. So how many units make up the class? 7 units, or 7 pieces, or 7 boxes. Well, if there are 7 units that make up the class and there are 35 students in the class, then how much is each unit? Each unit, 1 unit, would be 5 students. You said, well, Dr. Milo, where did you get that from? Well, 35 divided by 7 is 5 units. 5 is 5. So each box is representing 5 students. 1 unit, or 1 box. 1 box is equal to 5 students. All right, so if this is 5, this is 5, this is 5, and each one of these boxes are 5. So there's 5 here, 5 here, 5 here, 5 here. How many girls then are there? There are 20 girls. And just for the sake of the problem, there are going to be 15 boys. And I know that seems kind of, whoops. I need to undo on that. There are 15 boys. If we had shaded over it, it would have been kind of hard to see that the shading represented the boys, and then the whole thing represented the girls. I just didn't want you to get confused. So I wrote it as 2 separate tape diagrams, one representing the girls, one representing the boys. And I knew to draw this in fourths only because this fraction here, it said there are 3/4 as many boys as girls. So we had no choice but to represent the girls in fourths and the boys in fourths. Okay? All right, let's keep going. Number 6. All right, I think that this is probably the most challenging out of all of them, the problems that we have here. So let's just kind of take this one step at a time. We're probably going to write a tape diagram for everything that's happening here, okay? All right. let's dig in. So Ciro purchased a concert ticket for $56. So right now, all I'm gonna do is put ticket, and I'm gonna put $56. I do not know how much I'm gonna divide this into right now. I'm just gonna put 56. Okay, another ticket, $56. All right, it says the cost of the ticket. So that cost is 56. The cost of the ticket was 4/5 the cost of the dinner. So the ticket is 4/5 the cost of the dinner. So that means that the dinner is more than $56. Does that make sense? It's a portion of the dinner. 4/5. The cost of the ticket is 4/5 the cost of the dinner. So I'm going to draw dinner. Let's do a different color. Let's do green for food. All right, so here's the dinner. Are you with me? The dinner, it says the cost of the ticket is 4/5 of the dinner. What do you think we would do? What do you think we would do to the dinner, that dinner right there? You know we're going to divide it, right? So how many equal parts are we going to cut the dinner tape diagram into? What do you think? What do you think? Yes, it is 5. So we're going to take the dinner and divide that into 5 parts. Okay? Why? Because this fraction says that 4/5 of the dinner was how much? The cost of the ticket. So 4/5 here. We know that now we don't know how much the dinner was. All we know is that the cost of the ticket was 4/5 the cost of the dinner. So if this represents 4 pieces, this represents the ticket. It represents the ticket. Is everybody with me? 4/5 of whatever this dinner is the ticket. And we already know that the ticket is $56. So then how much is each portion here? Okay. We're doing that so that we can find out how much the dinner is. Okay. I know that the ticket is $56. The cost of the ticket is 4/5 the cost of the dinner. That means that the dinner is more than $56. Okay. All right, so if these 4 boxes represent $56, then how much is each box? Well, I've got to do 56 divided by 4. What do you get? 4 goes into 5. Is that wigging some people out? Maybe. Okay. 5 divided by 4. Or how many times does 4 go into... Dr. Milo, what's happening here? How many times is 4 going to 5? 1 times. So 1 times 4 is 1. I'm sorry, 1 times 4 is 4. 1, and I'm going to bring down the 6. And so then 4 goes into 16 4 times with remainder 0. So that means that each box represents $14. Okay, so there's a 14 here, and a 14 here, and a 14 here, and a 14 here. And if all 5 of these boxes are the same, that means that each box has a 14 in it, including this box down here. So since they all have 14, then how much is the dinner? The dinner would be the entire tape diagram. So that means it's 70. So it's 14. 5 14s are 14 times 5. So 14 times 5 is 70. So what in the world did I just found? I found the cost of the dinner. So now I have the ticket, I have the dinner. which is 70. Now I can keep going with my problem. And you notice what Dr. Marlum did. I didn't even go to the next piece of this. And that's what problem solving is taking it and breaking it into smaller components. All right, let's keep going because we're almost done here. Whew! All right, it says the cost of his hotel. Make the hotel orange. All right, so the cost of his hotel is what? 2.5 times as much as the ticket. Oh, 2.5 times as much as the ticket. So now I need to find the cost of the hotel. So it's 2.5 times as much as the ticket. So it's 2 of the tickets and then half of the ticket. Does that make sense? If you don't see that, that's okay. It's 56 times 2. And so you can write this as a decimal. You can leave it as a fraction. You can also see that you could do, if I want 2 56s, right? How much is that? Or 56 plus 56. Now, why am I doing that? Because it says that it's 2.5 times the cost. So this sometimes I can do this far quicker than I can just multiply this and change this or change in a decimal. Sometimes I can just do this. 56 plus 56 is what? It is 112. And then I have this half. So what's half of 56? Let's try this again. 56 times a half. Times a half, or a half of 56. Well, you could do the division, okay? How did you know it's going to be a division, Dr. Marlon? Because I can write this as 56 over 2. And so now I need to divide. Be careful. When you finish dividing, you should get 28. So 28, I'm going to add that here. This is just another way to be able to multiply numbers. So I know that it's 2.5 times as much. So what if it was just 2 times the cost of the ticket? You see what I'm doing? So this is 2 times the cost of the ticket right here, meaning 56 times 2 or 56 plus 56. But it was 2.5. So it's 2 56s and then a half of 56, which is 28. And so the cost of the hotel is $130. Did we answer our question? You know that that's one of Dr. Milam's pet peeves, is that you need to go back, make sure you read what it is that they were actually asking of you. How much did he spend altogether for the concert ticket, hotel, and dinner? So there's hotel. Here is dinner. Here is ticket. And so I'm going to add all of them up together. And I get $256. Not a bad night. $256. All right, that wraps up the lesson. This is lesson 24. So sorry that I did not have my objective up. The objective, though, was to be able to solve fraction and decimal problems. And so here's the objective. Woo! There it is, lesson 24. Solve word problems using fraction and decimal multiplication. All right then, ladies and gentlemen, get started on your homework. I'll post the homework video, and then I'll see you real soon.